Last video we learned how to evaluate a definite integral by using the fundamental theorem of calculus. In this video what we're going to do is look at an application and a property of continuous functions on a closed interval. So if you remember, mean value just simply means average value. So whenever we look at a function, call it f, and say that it's continuous on a closed interval a, b, just like this function. It doesn't have to be non-negative, but in this picture we do have a non-negative function. Then we know that somewhere in this interval, and it could be at either endpoint, there is a number c. And what happens with c is that c gives us a rectangle. So if I look at, say, this point right here, this c is a special c value in AB, where if we look at the area of this rectangle, it corresponds to the same value as the definite integral. So let me come up here and let's break this down in relation to this picture. So this value, or this length, is b minus a. And the height of this rectangle is f of c. So the area in the blue, this whole rectangle, is f of c times b minus a. And what we're saying is that area corresponds to the area over here. Another way to think of it is, if I take this blue line right here and I use that to chop off my function's top, this area up here can fit in this small region right here. We say that f of c is the average value of the function. So this is the same thing on the previous page, known as f of c. So this f of c is called the average value of the function, and that's typically the easier portion to find, and then go and find c after that. So as we look at an example, we have f of x equals 9 over x cubed, and that's on the closed interval 1 to 3. So it's continuous on the closed interval, so indeed the mean value theorem for integrals does apply. So let's go ahead and find first the average value. So to find the average value of f, what we know is it's going to be 1 over b minus a times the integral from a to b of f of x dx. In this case, we have 1 over, and then b is 3, a is 1. So we'll have 1 over 3 minus 1 times the integral from 1 to 3, and then f of x is 9 over x cubed dx. And this equals 1/2 times the integral from 1 to 3, and let's go ahead and rewrite that as 9x to the negative third dx to integrate using the power rule. So we have 1/2 times the integral, actually let's go ahead and integrate, raise the power on x divide by that new power, from 1 to 3. Now let's clean that up, simplifying. So this will be negative 9 over 2x squared from 1 to 3. So we have 1/2. Now substitute the upper and lower limits of integration in. So we have negative 9 over 2 times 3 squared minus negative 9 over 2 times 1 squared, which is 2. So that's the average value of the function. And that's the first thing that we were asked for. Now we're supposed to find the value of c that yields this average value. Now this is the simplest portion of the whole problem. So we're supposed to find the c such that f of c equals the average value. So our function is 9 over x cubed. We just want to know when that's 2. So solving that gives us 9 equals 2x cubed, or that tells us x cubed is 9/2. So x equals the cube root of 9/2. Now, we should rationalize that denominator. And to rationalize that denominator, we're going to multiply by whatever it takes to get rid of the cube root in the denominator. So I have 1, 2, so I'm going to multiply by 2 more 2's. And so that gives us the cube root of 36 over 8, or simply the cube root of 36 over 2. So therefore, c equals the cube root of 36 over 2, which is about 1.7. So let's take a look at the graph. So this is the graph of 9 over x cubed from 1 to 3. And what we've said is that if we build a rectangle that has the same base as this region that's been shaded, then the height would need to be a height of 2 in order to encapsulate that shaded area. So let's go ahead and build a rectangle that has the same base but has a height of 2. If we do that, then this green rectangle that I've shaded will encapsulate all of this magenta, this pinkish, purplish region. And when does that height of 2 get attained? And this is the value of c that we had calculated, which is about 1.7. So what's the significance of the height? This is the average value. Another way to think about this average value is if I add up, an average is just add up and divide by how many. So if I add up all of these heights and then I divide across how many there are from 1 to 3, then the height would be 2.